I can't. I gotta have like A's for B's. Since they don't have a lab, I might just either push physics or an A&P next summer. 8 credits.
Now tomorrow when you go to the lab there, and after the exam, we'll have the exam from 8 to 9ish. That's 1 hour, and then after the exam there, we won't have a lecture. And I figured I only have about probably 20 minutes left after the exam is finished there. There's no point of doing any lecture. You may just want to take a break there, and then go to the lab. When you go to the lab there, we're going to do the unknown part of the water hydration lab. You are repeating what you did yesterday. And we are going to give you a different chemical. This time it may be a white chemical, it may be colored and with different colors there. Yesterday you worked with a blue solid, and you try to get rid of the water by heating it, and then you come up with the formula there. Now you need to know how to do the calculation. There's a worksheet on page 72, I believe, and then you have to do the calculation for the known part. We finished all the activity, all the measurements yesterday. So you need to know how to do the calculation there. So hopefully tomorrow's lab is not going to be as long, because you already know how to set things up and what you need to do, how many grams of sample you need to measure out, and things like that. You had a procedure for the activity. You don't need to do another procedure for the unknown part. And if you look at the lab report requirement, 4 and 5 are combined together. Okay? I couldn't remember the page number, but at the end of lab number 5, and you see a page with the list of things that you need to include when you're turning your report. So your report for water hydration is a combination of number 4, number 5, together one lab report. That one lab report is worth 20 points, and it's due on Tuesday when you come to the lab again. And on Tuesday when you come to the lab, you will have a quiz as well. The quiz is going to be about the water hydration lab. So many things that we talked about yesterday and maybe tomorrow when we're dealing with the water hydration lab activities there, like the safe handling of Bunsen burner. Those are the things you need to pay attention to. Okay. How do you do the calculation? You need to know how to do calculation. How do you define constant mass? If we give you a list of mass measurements from as an experimental data, you need to know. You need to be able to determine which one is the constant mass, and which one is the constant mass that you're going to be using for the calculation there. And remember that 0.003 gram difference. If you have consecutive measurements, mass measurements there, the difference between two consecutive measurements, if the difference is equal or less than 0.03 gram, then the last measurement would be the constant mass there. So you have to take the difference, say if you have 3 heatings there, between the first and second, see if the difference is equal or less than 0.03. If it's not, then the second mass is not constant mass. You look between number 2 and number 3. It's a difference between number 2 and number 3 is less than 0.03, then mass number 3 is your constant mass. If you have a list of 5 heatings there, then you have to check between each 2 heatings there, next to one another. You have to check the difference. Okay. And sometimes the difference is very obvious, but sometimes you actually need to use a calculator, punch in the number, do the checking. So you have to know how we define constant mass. Constant mass is not that 0.003 gram, right? 0.003 gram is what we use to judge whether or not you have the constant mass. Constant mass is the mass after the final heating. Okay. And not necessarily the final heating there, but it's just the, between the 2 heatings there, it's always the one that you finish in the end, if the 2 masses are within 0.03 grams of one another. So that's about tomorrow's activity. You come in here at 8 o'clock for the exam. After the exam, you can go to the lab there. 9:30 we'll start the lab. Hopefully we will finish the lab activity before 12:30. It shouldn't take 3-4 hours tomorrow. Since there's no quiz, nothing is due. The quiz itself yesterday took about half an hour, more or less, and so That's a half an hour time saved. Okay, so well, welcome back, and we'll continue our chapter 4 discussion. And this is just something that we have to do in the summer. There, we don't really have a whole lot of time to review what we talked about, and we just keep going. And tomorrow is an exam. I know your mind is probably preoccupied with that exam thing. However, these are the things that we have to talk about, given the time frame that we have in the summer there. So chapter 4 deals with chemical quantitative analysis of chemical reactions there. So we need to, first of all, you need to understand what chemical reaction equation is all about. What do we know when we have a balanced chemical reaction equation? How do we balance the chemical reaction equation if it's not balanced? And we showed you how to balance the equation on the last part of chapter 3 there. So chapter 4, given a balanced chemical reaction equation, we need you to be able to do calculation. Now, balancing the equation is only the first step. Chemistry is a quantitative science there, and then you have to be able to quantify the amount of chemicals involved in chemical reactions. So this particular learning objective here, using a balanced chemical reaction equation, we need you to be able to calculate the quantities of product formed from a given amount of reactants. Or if you have the fixed amount of product that you have to produce, how much reactant do we need? So the calculation goes both ways. And with given amount of reactants, you can make predictions based on the balance equation. How much